So we're here to talk through this TomTom puzzle from Grant Fikes. One of the things with Grant's TomToms is he always leaves a lot of unclued cages. I mean, in some cases he wouldn't have even put the bold borders in here, but he wanted to sort of showcase that all the clues that are filled in are triominoes with a bend. The thing with unclued cages is you really sort of know that, rows like this, columns like this, places with unclued spots, you just can only fill at the very end of a puzzle when Latin square rules take hold. So if I were to mark places at the start to do anything in this column where every cell is in a cage, these two rows where every cell is in a clued cage, those are the spots to look at. And that will map pretty well to just your expectations with a TomTom in general. In a case like 1 to 7, we're going to look for extreme values. So one of the first things you should do mentally is say what is the largest sum that's possible in a puzzle like this. Something like a bent cage would allow a 7, 6, 7, which is a sum of 20. So this is as large as it can be. This obviously can also be a product. But the two clues at the very top must be products, and I'm sure everyone quickly got 5, 5, 1 as that's split down there. There's a 7 somewhere over here. And I'm going to mark the fact that it is one of two choices, 2 times 2 or 1 times 4. And you can sort of mentally store that, but it's important to sometimes track the digits that aren't yet written to the grid, but are part of the product, that these are taking even numbers or ones, but not 3 and 6 and 5, like, sort of things that don't have a prime factor 20, as we're going to run into pretty soon. So having filled this, let's still continue our focus on column 3, which looks pretty rich still. One thing we can note quickly, having placed the 5s, this now must be a summation. The 9, we can't say much about. The 20 looks pretty critical. If it's a product, the 5 can now be identified. We've actually cleared the 5 from this column, so this have to be 5, and this would have to be two numbers that multiply to 4. That's normally a 1 and 4, but 1's already there, so you can determine for yourselves from the two options, plus or times, that it's a sum. We've already talked about the limit of this being the maximal sum, so that's the breakdown you're going to put into the grid. From here, let's come back to the 10 plus. Why come back to this now? Well, when you have all but one left into the grid, you can start to think about the set of remaining digits, in this case 2, 3, and 4, and basically place what are any possible values that sit here. We know that it can't be a 5, so the sum of these two numbers can't be 5 themselves. 2 and 3 sum up to 5, which means that the only digit we know for sure sits in this space is the digit 4. There's a 2 or 3 here. But with this being a 4, there are two options. It's 2 and 4 sum to 6, so there could be a 4 in the spot. 4 and 3 sum to 7, there can be a 3 in the spot. Knowing this is going to be really helpful in just about a minute as we explore further this grid and some of the circumstances surrounding it. So having really marked as much as we can in this column, let's look at these two rows. And let's look at assigning sort of what is going on in these different cages. With the 7s already present, these are certainly pluses. Can this be a plus? Well, we've filled in some of the larger digits now, so we have a new maximum reachable to put into this spot. It's going to start by seeing that 5 and 4 is the largest sum for these two cells, so 9. Left over, we can place as large as a 6. So 15 is as large as this cage could be if it were a sum, so this has to be a product. 16 as a product is 4 times 4 times 1, or 2 times 2 times 4. And this is where, knowing how to solve this puzzle sort of helps me get to this step, but sort of having a mental view in your mind that, these 3 cells and these 3 cells are going to be filled with mostly even numbers that are limited, tells you that there's something special about how to fill the remaining cages up here. Specifically, there's an option which uses both 4s and at the same time would use both 2s, clearing these spots here from having 2s and 4s. The other option, 2, 2, 4, course, there's a 1, 4 up here, again using 2 2s and 2 4s. This cell can't possibly be a 4 because both of the 4s must be accounted for in these two cages to get this total set of products to work out. So as soon as we can actually eliminate that 4 and say, well, actually 3 is the only choice left in this cell, we make one of the big breakthroughs to get forward into this puzzle. And if you worked your way through to that spot, it's pretty great progress to see and really useful to continue. The next sort of typical but alternate way to look at TomToms, we're starting now to get into a kind of Latin square thinking mode, is we're now going to start reaching some spaces where it's just hard to place a particular kind of digit. Like we place these 2 5s early on, where does the 5 come into this column? Well, it can't be down here in this product. It's going to be in one of these 3 cells. It turns out when we have mostly even products, except for this one unaccounted for, this 7 right here, things like 3s, 6s, and 5s don't have anywhere else to go in this column, so collectively these 3 cells you could think in your mind as a 3, 6, 5 triple. We actually have 2 3s placed. So the third 3 is right there. This is a 6 and a 5. Having gotten that 3, we now get to play with some of the low clues, and one of the things Grant does a lot in his puzzle is actually play with these extreme low values. This is certainly not an addition or multiplication cage. If it were to be a division, if this 3 were the numerator in that setup, you'd have to have 2 1s over here. That's not likely. Otherwise, now you need a digit that you're dividing into that has 2 multiples of 3, so you need 9 or something larger than 9 to fill that role. This can't be a division. This is a subtraction. It being a subtraction, the 3 is not the thing that's being subtracted from. This is one of the things that's being lost. So this plus one other number, so 6 plus one other number looks like 6 and 1. 7 is the total thing we're subtracting from. So 7, 1, 3 is the only way this cage works. The 7 can't come down here, so the 7, 1, 3 has to split like this. We've talked about how hard it was to place 6 and 5 in this column. Well, in this column, 6 is still pretty difficult to place. It can just be here, get to a spot like this. And this will be where a lot of solvers will sort of stall out until they work through this bottom bit, and specifically assign what this value can be. There are a few ways to do it. One thing you can think about is sort of, while you know these 2 breakdowns of potential sums, they give you a sum constraint in this column. There are only 2 potential values that can be, just from knowing that there are 56 total is the total sum of these bottom 2 rows. There's an easier way though, which is we need to place a 5 and a 3 down in the bottom. We know it's not over here, so somewhere on the right here is a 5 and 3. We already said this is 7 plus. A 5 going to 7 plus is pretty unlikely, so let's think about that for a little bit. 5 in this row would require a 1 and a 1. We can eliminate that now, so the 5 has just 1 spot left for it. The 3 comes somewhere over here. It's going to sit with a 1 or a 2. We don't know which. That's going to leave a 2 or a 3 in the cell. So having mostly marked the bottom row, will be a 4 down here. Let's come up 1 row more, and let's think about where a 5 can go. 5's not going to go in either of these cells. We now understand that. It's not going to come right above here, so it's got 2 choices. If a 5 is there, having figured out that this cell is a 2, 5, 2, and 2 would be no good. So the only real location for, is right there. 5 and 4 leaves 2, 3, and 6 in this group. Again, 6 is in there, 6 is in there, 6 is the leftover. You get a 1. We do still now need to place a 3 in this row. 3 can't be right there, so this is the 3 that fills out. This is 3 and 1. This is a 2. The bottom product's a 2, 2, 4. The top product here has a 4, so it's a 7 with a 1. We have a 1. And sort of we get to having most of an L shape in this mystery L puzzle filled. And it's just the fact that because the cages are working so closely together that there'll be a quick domino effect happening there. So let's shift a little into Latin square mode for a while. We need to deal with some of these rows. We have 5 of the 7 5s placed, so in this row we need a 5, in this row we need a 5. Those are the only spots. Having this 4 here, we can fill out the rest of this row. We need a 4, 6. This is the only set. Up here we have 1, 2, 7. We can only say there's a 1 somewhere. I see that there are 5 1s. So there's a 1 in these two cells. That's one of the things we may want to think about. We can also consider that there's a 3 here and a 3 there. That will finish out the 3s. We can mark that there is a 4 here and a 4 there. That's not as useful. There is a 6 here and a 6 here. We have 3 7s to go, so there aren't as many notes I want to write about them. We have a lot of 2s to place. We have 4 2s to place. So this is about all the either or notes that are going to come into the grid right now. So let's switch back then to thinking about the cages themselves. We have a 1 and a 15. The 15 seems much more enticing right now than the 1. Particularly when I see that I could be placing another 1 in a 15 cell. That makes me think if a 1 is here, we're probably getting 7 and 7. That's no good. This being a product, all the 5s are used. Placing a 1 into this cell is almost never going to work for a 15 clue, certainly not at this stage in the puzzle, so we can steer those right away. We now have still to think about this clue. We can say it's a sum. Whenever I have a cage where I can determine, and this is the same situation with the 2, 3, 4 we thought about here, I can determine 2 of 3 members of the potential pair. I sort of want to go through the inventory of all the choices. A 15 sum that had just the low digits here, 2 and 4, would require a 9. That's no go, so there's certainly a 7 in this group. The 7 can come with a 2 or a 4 with with 8 left over. That would place a 4 or 6 up here, depending on which it goes. The 4 is a no-go, so this must be a 6 from having considered all the possible pairs in this group. This being a 6 makes that a 7, 2. This is the 4. Push up that note for a 4. We're going to have another 7, 2 here, so the last 6 is there. This will be a 7, 2. This will be a 7, 2. This is a 3, 2. We're going to have to think about this one cage last. You should recognize with all the 1s spent and a 3 included in it, this can't be a division, it's going to be a subtraction. Right now, whether this is a 3 or 2 up here, we have 2 smallish numbers, so we need a big number in there. Particularly if I said this cell was a 7, this will be another 3, 2, 3, 2, and 2, and 3, 2, and 3. It just aren't going to work. So you can mentally prepare yourself that 3 and 7 is there. That means the last number is a 1, and now we just have a cascade of finishing the remaining cells to complete the puzzle. So this, surprisingly for its size, ended up being a rather hard puzzle for our solvers to finish. I think the reason is that it actually has a quite limited solving path. The highlights being sort of working in this space, this column, this row. Ways to get at this cell, which we're using partial sums. Ways to use collectively these 2 clues to say that the even numbers, the 4 and 2s, are all spent in this space, so there are no more 2s and 4s anywhere else. That eliminated there. Got that whole clue in, got a 2 there. That then lets you come across and think about, again, 5 3s down here to work your way through. So, it's sort of a range of steps along the way, maybe some things you could learn. Certainly some of the notation may be helpful, and times when you actually sort of want to think about, particularly when you just have 2 breakdowns of products or sums, sort of have them mentally in your head when you're looking at the puzzle, because you'll catch how the digits work together that way better. We'll see you again soon.